galaxies.
And what about in your studies? How does dark matter sort of affect things? Is there any sort of observation you come across in which you think, this looks a little bit inconsistent with things?
Well, not in the research work that I've done. No, it doesn't sort of affect things on a star formation scale. It affects things on a galactic scale. So the reason one of the main reasons we think dark matter is there is by looking at the H1 line and looking at how fast galaxies are rotating. So if you look at a galaxy in the optical part of the spectrum, you measure how many photons you get from it. And you look at an average star like the Sun, we know how many photons we get per second from the Sun. So if you divide one by the other, you've got an estimate for how many stars are in the galaxy. You know how much the Sun weighs because we can measure how fast things are orbiting in the solar system. That gives us an idea of how much it weighs. And then you multiply that by the number of stars in the galaxy and you've got a mass for the galaxy. Okay? If you do the same thing with the H1 line, you look at a galaxy and you measure its rotation curve, the speed of the stuff moving at the outside is where it's moving fastest. That speed tells you how much matter there must be in the middle. And if you compare those two numbers, they're different by quite a bit. So that's where we think dark matter comes in. It's the difference between what we can actually see and what we actually measure in terms of how fast the stuff is moving in the outside of the galaxy.
Wow. And I guess also even when you're having merging galaxies, I guess you have the centres merging with black holes and all kinds of gases happening at the centre there, and all kinds of sort of radioactive galactic nuclei, I believe they call it.
Yeah, that's right. So active galactic nuclei, you basically got a supermassive black hole at the middle of the galaxy, which is accreting material from the galaxy itself and generating two enormous great big jets of radiation. There is a supermassive black hole in the middle of our galaxy, but luckily for us it's not accreting material and sending out huge jets of material. When you get galaxy mergers, eventually, yes, it takes millions and millions of years, but eventually, yes, those black holes will come close to each other in the middle, and eventually the idea is they will actually merge, and that will generate gravitational waves. So that's what gravitational wave detectors are actually trying to see, is the signatures of merging black holes.
Do we know whether that also produces gamma ray bursts as well? Do you merge them? Or?
Well, gamma ray bursts, the idea, well, there are various different kinds of gamma ray bursts, and one of the ideas behind those is that it's actually more to do with the explosions of stars. So supernovae at the end of their lives, very, very massive ones. The idea is that those are possibly what are causing gamma ray, well, one particular kind of gamma ray burst.
Right. But merging, who knows?
Who knows? We don't know all the answers yet, thankfully, otherwise I'd be out of a job.
Pretty boring sort of industry.
It would.
What other sort of projects are on the or being developed in WA that you're aware of that we may possibly be leading lights in?
Well, in terms of so before the Square Kilometre Array, so it's a telescope, we've never built anything on this scale before, and it's involving a lot of new technology. So before we build the Square Kilometre Array, we've got to know how to build it. So we're building a lot of precursor telescopes and demonstrators, and there are two of those being built here in Western Australia. One of them is called the Murchison Wide Field Array, which is a low frequency telescope, which is basically a set of static dipoles that sit on the ground and basically observe the whole sky. And you use electronics to actually steer the beam. So there's no moving parts, so there's no mechanical things to go wrong with it, it's all done electronically. And the other telescope that we're constructing is called ASCAP, the Australian Square Kilometre Array Pathfinder, which is more like a traditional radio telescope. It's a series of 36 15-metre, I think.
Or thereabouts.
Or thereabouts, yeah. It's a set of 36 radio telescopes that are all going to be sat out in the Murchison in Western Australia.
Right. It's going to be a pretty exciting time for astronomy in WA, I think, over the next few years.
It is. It's it's really exciting.
So in terms of trying to encourage more people to actually get into the sciences, what would you recommend to anybody listening in?
Go for it. I studied science I knew what I wanted to be when I was really, really small, and a lot of the kids that I've spoken to, the things that excite them are astronomy. They love looking at pictures from Hubble and whatever. So if kids are interested, study science and maths, and just basically follow whatever you're interested in. Because if you're not interested, there's really no point, you know.
Right, that's true enough. And so in terms of possible further outreach material, are there any sort of web resources or other resources you recommend to get people started and find out a little bit more about what we've been discussing today?
Yeah, sure. Well, one of the best places to start is probably the ICRAR website, so www.icra.org, which is my organisation. But there's also an awful lot of information out there from places like the National Radio Astronomy Observatory in the US, so nrao.edu. They have a lot of resources on there as well, and ideas to help you build your own radio telescope as well.
Right, fantastic. Dr. Megan, thank you very much.
You're welcome.